Hello everyone, welcome. This is your third chapter, Distributed Computing Paradigms. Paradigms and abstractions. Abstraction is an idea of encapsulation or detail hiding. It is an provision of tools or facilities that allow software to be built without the developer having to be cognizant of some underlying complexities. So here developer will not have to deal the underlying complexities, so it will make the programming easier. Okay, the operating system will handle all the underlying complexities, or the details are hidden, so it will not be shown to the developer, so that the programming will be easier. Okay, so here the paradigms, see the level of abstraction high to low downwards, and at the lowest level message passing paradigm and client server, peer to peer, remote procedure call, remote method invocation, network services, object request broker, mobile agent, object space, and collaborative applications. So these are all the paradigms, distributed computing paradigms. At the lowest level we have message passing, and at the highest level object space and collaborative applications. So these are all highly object oriented paradigms at the highest level of abstraction. So here paradigms for distributed applications. The first one is message passing. Okay, so here at the lowest level it is message passing, the message passing paradigm. The basic approach to inter-process communication is message passing. In this paradigm, data representing messages are exchanged between two processes, a sender and a receiver. Okay, the basic approach to inter-process communication. So inter-process communication means communication from one process to other. Okay, so this is done through a message passing. Okay, so in this paradigm, data representing messages are exchanged between two processes, a sender and receiver. So in this this is the most fundamental paradigm for distributed applications. This is most fundamental and simplest form of paradigm. A process sender sends a message representing a request. The message is delivered to a receiver, which processes the request and sends a message in response. A sender sends a request and receiver processes the request and sends response. The reply may trigger a further request, which leads to subsequent reply, and so on. So after receiving response, the sender may send another request, and which leads to subsequent reply, and so on. So here the basic operations required to support the message passing paradigm are send and receive. The basic operations are send and receive. For connection oriented communication, connect and disconnect is required. For connection oriented, the communication is done through first of all they will establish one special connection. Okay, so the abstraction, so for a the connection oriented communication, connect and disconnect is required. The abstraction for this paradigm is served at operating system level, so that programmers may make use of operations to send and receive message without having to deal with the underlying details, that is the abstraction is provided. So here abstraction is provided by the operating system, so the programmers will not have to deal with the underlying details or underlying complexities. So all the underlying complexities will be handled by the operating system, so it will make the programming easier. So this is the message passing paradigm. See, process A and process B, M1, M2, M3 are messages. See here, process A sends message M1 to process B then sends message M2 to process A. Finally, process A sends message M3 to process B. This is a simple message passing paradigm. There is one more. The next paradigm is client-server paradigm. In this paradigm, the server plays the role of a service provider, waiting passively for the arrival of request. The other is client, issues specific request and awaits the response. So here client-server paradigm, one client and server. So server always it passively waits for any request. Okay. The other side it is client, it issues specific request and awaits the response. So here what happens is server processes the request sent by the client and sends the response. So client issues request and awaits response and it receives the response. Okay. So this model provides abstraction for the delivery of network services. So many internet services support client-server applications like HTTP, FTP and domain name services, etc. So these are all the internet services which rely on the client-server paradigm. So this is how the client-server paradigm works. There is a server host and multiple client hosts are there. A client process, a server process and a service. See, client process sends a request to server process. Server host holds the server processes and services. So the client process sends request to server process and server process processes the request and it sends the particular service to the client host. Okay. So here this is client server paradigm. So server host the server process will invoke the service. Okay. It will invoke the particular service and it will send it to client process. So here next paradigm is the peer-to-peer paradigm. In this paradigm, the participating processes play equal roles with equivalent capabilities and responsibilities. So each participant may issue a request and another participant issue a request to another participant and receive a response. So in this paradigm, each participating processes play the equal roles with equivalent capabilities and responsibilities. But here in previous paradigm, that is client-server paradigm, client plays a role of client, that is sending request, and server plays a role of server, that is always listens to any listens for request and sends response, isn't it? But here client peer-to-peer, each process plays equal roles and equivalent capabilities. That means each participant may issue a request to another participant and receive a response. See, this is peer-to-peer paradigm, process 1 and process 2. Process 1 sends request and process 2 sends a request and process 1 sends response. So subsequently, process 1 sends request and process 2 sends response. So each process is having equal capabilities and equal roles. Next paradigm is the message system paradigm. The message system or message oriented middleware MOM is an elaboration of message passing paradigm. In this paradigm, a message system serves as intermediary among separate independent processes. The message system acts as a switch for messages through which processes exchange messages. A sender deposits a message with the message system, which forwards it to a message queue associated with each receiver. So here this message system paradigm, in this we have one message system. Message system acts as intermediary or a middleware. Okay, message system is a middleware or intermediary. It will receive messages from the senders and it will send that messages to the corresponding processes. Okay, so here this is message system paradigm. Senders deposit their messages to the message system. See the message system in middle, it is a middleware. So senders deposit their messages with message system, and this message system sends the messages to the receiver. Okay, and receiver, it will deposit the messages to the message queue of a receiver, and receiver will extract the messages from message queue. Okay, see here there are two subtypes of message system models, the point to point model and publish subscribe model. First one is point to point model, message model. In this model, the message system forwards a message from the sender to receiver's message queue. Okay, so in this model, message system is there. Message system, see the message system is the middleware. Okay, it is a software which acts as intermediary. So which acts as intermediary between sender and receiver. Okay, message system is a middleware. See here in this model, a message system forwards a message from the sender to receiver's message queue. Okay, sender to receiver's message queue. So receiver is having its own message queue. So message system will pass it to receiver's message queue. Receiver's message queue, the middleware provides a message depository and allows the sending and receiving to be decoupled. That means it will share it to the sender. Okay, it will share it to the receiver. Via the middleware, a sender deposits a message in the message queue of the receiving process. A receiving process extracts the messages from its message queue and handles each message accordingly. Okay, middleware deposits a message in the message queue of receiving process, that is receiver. A receiving process, that is the receiver, extracts the messages from its message queue and handles each message accordingly. Okay, so there is one more, that is publish subscribe message model. Under message system paradigm, we have two subtypes, point to point model and publish subscribe model. See, first one is point to point message model. Next is publish subscribe message model. In this model, each message is associated with the specific topic or event. Applications interested in the occurrence of a specific event may subscribe to messages for that event. When the awaited event occurs, the process publishes a message announcing the event or topic. The middleware message system distributes the message to all its subscribers. Okay, so here the message is associated with the specific topic or event, and applications interested in this specific topic or event, they will subscribe to that message for that specific event. Okay, when that event occurs, the process publishes a message announcing the topic or the occurrence of topic or event. Okay, the middleware message system distributes the message. That means the subscribers will get the notification of occurrence of event or topic. The middleware message system distributes the message to all its subscribers. So this model provides abstraction for multicasting or group communication. So multicasting is group communication, one to all. The message is sent from one process to all, or it is called group communication. The publish operation allows a process to multicast to a group of processes, and subscribe operation allows a process to listen for such multicast. So here we have two operations, publish and subscribe. Publish operation is operation allows a process to multicast to a group of processes, and subscribe operation allows a process to listen for such a multicast.